Okay, in this video, we're gonna just look at how drafting has evolved as an industry and a career over the years. So, drafting is kind of considered almost like learning a new language. So, before we ever had verbal language, humans communicated to each other through drawings to kind of help alert others and give symbols. So if you think back to, cavemen and them drawing different animals in their caves, sometimes as a warning, sometimes just to tell stories. Drawing is kind of that first language that we ever really had. And then it evolved into verbal languages, but they've evolved even further now. So at first, drawing and sketches were just straightforward depictions of what we saw. They were kind of crude, but they got the point across. Then we had some artists come into play, such as Leonardo da Vinci, who is considered to be kind of one of the first main engineers to come about. He studied the world around him to help him create all of his different inventions. And he also used drawing to kind of help depict to others what he was creating, especially to get help from others, to help manufacture these pieces, but also just to kind of explain it to himself. He made lots of different drawings to help understand those products and how to help people reproduce those products. So there's lots of different drawings out there on the internet of Da Vinci's that you can see. There's also I believe it's either in Charlotte or Raleigh, but there is a museum where they have lots of his drawings and then even replicas of his inventions there that you can go visit, and it's really, really cool. But he made these drawings so that others could understand what he was making and how they worked and how the different pieces and mechanisms fit with each other. What really made drafting as a career come into such high prevalence was the Industrial Revolution. So, machines and mass manufacturing made a need for technical drawings of our objects so much more relevant and important because you had several people making the same parts and pieces. So if I'm a blacksmith working alone, I don't necessarily need drawings of what I'm making because I know in my head what I want the end result to be and how to get there. However, if I'm just telling someone, "Oh, I need you to make this gear for me," they need a little bit more information because they don't necessarily have that same vision in their head that you might have of that gear or whatever it is you're making. So technical drawings became a necessity and a standard since multiple people were making the same products and they all needed to be the same in the end result. Now, another thing that became prevalent from the need of those drawings was a need for these drawings to be standardized. So the issue that people were faced once we started making drawings of our products was that everyone drew them a little bit differently. And in order for manufacturers to be able to read the drawings without necessarily having to keep going back and forth with the designer themselves, there became this standardized method for laying out your drawings, how to note measurements on those drawings, how to note materials, how to place information of the drawing so that they could be understood by multiple manufacturers in different states and even sometimes in different countries, so that this way we all can manufacture these standardized products without having to go back and forth and communicate so much with the designers and the builders. And so here's an example of just kind of one of those standardized drawings of a little bracket, and how it is laid out and where the measurements are placed are all kind of just part of that standard fashion. So things that exist in drawings that that we started with and exist to this day are things like a title block. So typically at the bottom of the page or in the bottom corner. In architectural drawings, we'll typically find it vertically on the side. And your title block will have pieces of information about who made the drawing, what is it of, what size is it drawn at, which would be referred to as a scale. So how big is it in real life to compare to how big is it on the paper. And then a layout of the drawing itself. And this is what we call orthographic projection, which we're going to go over in Module 4 of the course. And so orthographic projection allows us to see the three-dimensional object from multiple sides or multiple views. And it then allows us to create quick and easy dimensions or measurements from specific points, so that this way we can see what does this object look like if we were looking at just the front of it and we weren't able to see anything related to the depth, or what does it look at from just the top and we don't necessarily see anything from the height, or just the side and we don't see anything about the width. So orthographic projection takes those several different sides or several views or faces of the object and projects that three-dimensional object two-dimensionally. Again, too, with a nice standard is having a 3D view of an object on the drawing as well. So this is called an isometric, which we'll also go over how to make one of those in the course. And then in this particular case, since it's made out of sheet metal, they also show what it looks like when you're manufacturing it just out of a flat piece of sheet metal. So all of the different measurements and how they're placed, the different symbols that maybe are included in the measurements. So for example, that this has a diameter of 12 and this curve has a radius of 5. All of those different pieces of information are included in there and placed and denoted in a very specific standardized way, so that this way I could go manufacture this bracket without having to talk to the person who made it at all. And we'll go over all of those standards throughout this class. So as I mentioned, these specific types of views, the specific layout of them, the different symbols we use in drawings, the different way we place our measurements all became standards. And now there are two main areas of drafting that we'll go over kind of in the careers portion of engineering and architecture. And there are different standards associated with those two fields, purely just because I'm not going to lay out a drawing the same way I would if I was designing, for instance, if I was designing a water bottle. I'm not going to design it the same way that I would a skyscraper. So there are some differences within those two areas, but a lot of the same principles still apply. Now, when it comes to the drafting office, when drafting first started as a career option, there were no computers. So everything started with hand drawing, and we had drafting desks and specialized furniture and equipment to produce our drawings. And so in this module, we'll look at some of those pieces, as well as in Module 3, we'll look over some of the hand drafting equipment, some of the stuff that came in your drafting kit. Because the job required a lot of attention to detail and some even larger drawings with attention to detail in them, there were these specialized desks that were just a little bit larger, and they would have some of the equipment attached to them. And a lot of times too, they'd be a little higher up, because draftsmen would often do the drawings standing up, or at least on a higher chair, to kind of help prevent some strain on the back. Now that we have computers and computerized drafting, there's been a shift towards a more minimal drafting desk. So while in my in-person classes in our classroom, we do have larger hand drafting desks, you'll see in a lot of classrooms and even a lot of studios now where they may have 1 or 2 desks available for hand drafting, but then most of the designers and architects are just working at a regular computer desk. just because so much of their work is done on the computer. So, software that helped change the game for drafting really started picking up in the 1980s, and one of the biggest companies around for CAD software, which is computer aided design or computer aided drafting. One of the biggest companies out there is Autodesk. So we were going to be using Autodesk software in our class. We're going to be using this software called AutoCAD, which is one of the first ones they released. It is a 2D drafting software, so it is going to be similar to the two-dimensional hand drawings we do, but it'll just be a little bit faster and a little bit cleaner to create our drawings with. One of the reasons why Autodesk has become such a large, prevalent kind of piece in drafting is not only just the quality of their software is very high, and their software is considered one of the easier ones to use and learn, but they also provide it for free for students. So the software itself is pretty expensive. You can look on their website, and it's usually around $2,000 a year to kind of get a subscription for some of their software. AutoCAD, the software we'll be using, is one of the cheaper ones, where I think it's around $900 or so a year, which to me, $900 is still a lot of money. But as a student and as a school, we're able to download the software for free. So you can make a student account and you can download the software for free on your computer if you have a personal computer to use and learn. And as a teacher, I can put it in my computer lab for free, and I can give you guys your Windows laptops with the software on it for free. And the reason they do that is because if I learn the software, chances are then when I go into the industry and I have to pick a software to use, I'm going to use theirs. So while they may be losing a little bit of money giving the software to schools and students for free, they're making that money up tenfold, because then all of the draftsmen out there are only ever trained to use their software. And their software is great, but I do think it's super nice that they allow us to learn it for free. And as I said, AutoCAD is kind of considered the introductory software, and it's just like having a giant piece of graph paper to lay out our lines and drawings. And the benefit of AutoCAD compared to hand drawings is that it's much easier and cleaner to make changes to our work. So we can work faster, we can test out a few different options and ideas without necessarily having to worry about some of those issues that might arise when I'm doing a hand drawing. And it's just considered a faster way to work for some. For others, maybe they just prefer hand drawing better. And then there are other softwares that various companies offer, but just looking at some of the softwares that Autodesk offers as well. So AutoCAD is considered the basic software, and then in some of the upper level courses, I teach these other softwares. So Inventor is a 3D modeling software, and it's referred to as a parametric model, which means it goes off of some sets of rules that I apply to the 3D object, and it kind of builds it out from there. It's used heavily in mechanical engineering and industrial design. So you build everything as a 3D model, and it'll make some of those 2D drawings, like those orthographics, for you. And if you wanted to do things with like 3D printers and stuff like that, Inventor or Fusion 360 would be the way to go. So Fusion 360 is similar to Inventor, but it has a couple of more features to it. It's easier for multiple people to work on a same project, as Fusion 360 is cloud-based, much like kind of Google Drive. And it has some CAM capabilities as well, which is computer-aided manufacturing. So you can actually model your three-dimensional part and then send it to things like a CNC machine, which is computer numeric control, and the robot essentially in that machine can then make your part for you. So if you're interested in kind of 3D modeling, mechanical engineering, industrial design, these two softwares, Inventor and Fusion 360, you can download them for free as a student. Not on the school Windows laptop we gave you, unfortunately, but if you do get a computer of your own one day, or maybe you have one yourself, you can download those, and there's loads of helpful tutorials and classes out there on YouTube for you to help learn those. Or who knows, maybe one day I'll offer those again as a virtual academy option as well. I hope one day I can. But they do need a Windows computer, so make sure you don't get a Mac. And then another software too, so if you're more interested in architecture, software out there called Revit, which is a BIM software, or Building Information Modeling. And so it creates a large three-dimensional model of the entire building with loads of information about the different components and pieces in the building. We'll go over BIM in a little bit more detail later in this module. But Revit then is the software that the architecture industry is moving towards. And it is also an Autodesk software. It is also available for free with a student download. There's also so many videos out there that are helpful to learn it. I have a few up on my YouTube channel, or I have kind of one tutorial walkthrough. It's about 27 different videos walking through a big project. And it's also a Windows only software. So depending on which side of drafting you're interested in, if you are interested, those are kind of some of the other softwares you can transition to after AutoCAD. Now, I always like to kind of think and imagine of what's next for drafting. So we had this shift from hand drawing into 2D CAD, 2D computer drawing, and now there's been this shift towards 3D modeling. And even then, the architecture industry has shifted towards 3D modeling. I always like to think of what's could be next. So one of kind of the last steps of this module is for us to kind of look at and discuss some of the things that could happen later on in drafting. I definitely don't think where we currently are is where we're going to stay forever. And I find it kind of exciting and cool. I think we're going to see a big shift towards virtual reality and augmented reality, but maybe we could even go a completely different direction. Who knows? So we'll look at that at kind of the very end of the module.